everybody, I'm Miss Cooksey, and today we're going to be talking about the building blocks of geometry. So these are very basics of geometry. We're going to learn about points, lines, planes, and line segments. So what's really cool about geometry is that geometry starts with these small building blocks and then builds up from there. So when everything we learn in geometry is going to correspond with these building blocks of points, lines, and planes. So let's go ahead and start talking about these three building blocks. The first thing we're going to learn about is a point. So a point is a location in space. Make that smaller. Please excuse my dogs in the background. They're really needy. A point is a location in space. So it's going to look like a point with a letter next to it. And that letter is the name of the point. So it'd be named as point A. Some things to know about points is that points have no size or shape. And that points can be collinear or non-collinear. Collinear means that they are points on the same line. And that brings us nicely into lines. So a line is made up of an infinite number of points. It also has no thickness or width. So it's just an infinite number of points and it's infinitely narrow. So a line is infinite, so it's going to have arrows on both ends. Sometimes you'll see it with usually a cursive letter next to it. And we know a line is made up of points. So when we name our line, we can name it a couple things. We can name it using the cursive letter. So this is line M. We can also name it by the fact that it has some points on it. So this is also line AB, and we know it's a line because we're actually going to draw a line with arrows on top. We pick 2 points along that line and then draw a line with arrows on top. Or we can call it line BA. Both of these are names for a line. So a couple facts about a line that it's worth knowing. First, it has no thickness or width. Second, there is only ever one line. Through any 2 points. Finally, where lines intersect, they always intersect at one single point. Okay, again, excuse my dogs. We're going to move on and talk about planes. So this is not an airplane. This is a plane in geometry, which is a flat surface made up of points. So it's going to look like typically some sort of parallelogram or rectangle, and it's going to have a bunch of points on it. Sometimes you'll also see a little cursive letter. So a cursive P. So we can name it a couple different ways. We can call it the cursive letter on the plane. So this would be plane P. Or we can name it by 3 of the points on the plane. So this could be plane ABC, plane BAC, plane CAB, and etc. So we can name it using any 3 points that are on the plane. Some important facts about planes is that they extend indefinitely in any direction. So although this looks just like a rectangle, it's actually extending off in every single direction. It's created by 3 non-collinear points. The reason that they're non-collinear is because if they were collinear, it would just be a line. They would be totally straight. When you add a 3rd point out here, you start to get a 2-dimensional surface. And planes always intersect. So if you have 2 or more planes intersecting together, they will intersect at a line. So let's do some practice with this. We're going to start by creating a diagram. So we're starting with lines MN and PQ. So I'm going to go ahead and draw a line MN and line PQ. And they intersect at point R. Line MN lies in plane A, but PQ does not. So I'm going to go ahead and draw a plane. And I'm actually going to get my eraser out and kind of erase down below. That way you can see that PQ is going through this plane, but it's not actually on the plane. And this is called plane A. So let's go ahead and give it a little cursive A to name it. Point B lies in plane A, but is non-collinear with either line. So we're going to go ahead and put point B not on either line. Okay. Now we can go ahead and answer a couple questions about this diagram. The first thing is to name 2 sets of 3 non-collinear points. So points B, M, and P would be not, oh, sorry, this is collinear. My bad, I skipped a question. 3 collinear points. So points M, R, and N are collinear because they all lie on the same line, and points P, R, and Q are collinear because they all lie on the same line. The non-collinear points, so points that do not lie on the same line, this means none of the points can lie on the same line. Not 2 on one line and 1 off, none of them can be on the same line. So I'm going to say points B, M, and Q are non-collinear. Two coplanar lines. So these are going to be 2 lines that exist on the same plane. We see one line that's definitely on the plane, that's line MN. But a line, even if it's not drawn yet, is just any connection between 2 points on the same plane. So I'm going to go ahead and list line BR as also being on this plane because point R and point B are on this plane as well. Next, name the intersection of plane A, sorry, that should say plane, not plan, plane A and PQ. So PQ intersects plane A at point R. Next, name the intersection of PM and MN. So PM, let's make this purple line. goes here, it's not part of the plane. It's going from P to M, and it's intersecting M in at point P. Point M, I'm sorry. Give another name for plane A. Well, to give another name for plane A, we need to list 3 non-collinear points. So we would call this plane BMR. And then last, name 3 planes other than plane A. So a plane is just a grouping of 3 non-collinear points. So we could have plane BMQ, which would be a plane that goes a little bit diagonal to the plane that we have right now. We could have plane MNP, which would go almost perpendicular to the plane we have right now. We could have plane BQN as well. These would all be different planes than plane A. So these are our basics: points, lines, and planes. Everything else we'll do is going to be made up of a combination of points, lines, and planes. So speaking of points, lines, and planes, let's talk about a line segment. So a line segment is a segment with 2 endpoints. So this is like, while a line goes on forever, a segment stops at a point on each side. There's also a combo of a line and segment called a ray that stops on one side and goes on forever on the other. So, as I just said, a line segment looks like a line but having 2 endpoints, and each endpoint is named. And it's named similar to a line. You would call it segment AB or segment BA. You might notice that we don't put dots on the end. The lack of arrows assumes that there are endpoints here. Okay. One fact about a line segment is when we talk about the measure, so the length of line segment AB is called AB. So if we're talking about the actual length or the measure, we don't put that line on top. And that will make a little bit more sense as we move to proofs later in this course. So now let's look at a more complicated line. So here's a larger line. This is line AC. But inside line AC, there's segment AC. And then inside segment AC, there's segment AB and BC. Point B is between points A and C. If and only if points A, B, and C are collinear, so B is in between as long as they are all on the same line and AB plus BC equals AC. So one of the things geometry loves to do is write things in like very academic language that have pretty easy logical explanations. This means the 2 smaller segments added together equals the bigger segment. So let's see what that looks like in practice. So my smaller segment is AB is 4.3 and BC is 3.1. AC is going to be 7.4. So 4.3 and 3.1 is 7.4 centimeters. We can also do this with subtraction. So if AC is 9 and I take away AB, which is 5 and 3/16, then I know that BC, what is left over, is 3 and 13/16. We can also solve problems using segments if they're written as word problems. So find the value of x if a, b, and c are collinear, b is between a and c. So I'm going to draw a diagram because I am bad at solving these without a diagram. So a, b, and c are collinear, b is between a and c, ab is 4x, bc is x plus 5, and ac is 35. Now I'm going to use my algebra skills to solve this. 4x plus x plus 5 equals 35, which means 5x plus 5 equals 35, which means 5x equals 30, and x equals 5. Awesome. There's one more vocabulary word in this lesson. We're going to learn the word congruent. Congruent, this is the symbol that means congruent, and they are segments that have the same measure. So in algebra, we'll use the word equal. We use equal when talking about numbers. We use congruent when talking about shapes. And even if we do not know the numbers for the sides of the shape, but we can prove that they're the same measure, they are congruent. We note congruent segments by using these tick marks. The same amount of tick marks means that they are congruent. So in this shape, we can write that segment AB is congruent to segment BC, and that segment AE is congruent to segment CD. We know this because AB and BC have the same amount of tick marks, and AE and CD have the same amount of tick marks. In FGH, we have one side length that's 3, one that's 4, and one that's 5. So no segments are congruent because none of them have the same measure. Finally, we are going to look at this parallelogram. This time, we are actually given some measures, so we could use our deductive reasoning to know that if IL is the same as JK and IL is 1 inch, JK is also 1 inch. And if IJ is the same as LK, IJ is 2 inches, LK is 2 inches. So if I want to write that out, I would write that segment IL, is congruent to segment JK, and segment IJ is congruent to segment LK. So in this video, we learned a lot of new vocabulary. We learned what congruent means, we learned what a line segment means and how to find measures of segments, and we learned about the basic building blocks of geometry, a point, line, and plane. All geometry is built off these three concepts. We use points to make lines, we use lines to make planes, and then we combine them in a whole lot of different ways, and that makes geometry. Thanks for watching. I hope this video was helpful. Make sure to press that subscribe button if you're in my class so you never miss a video, and I'll see you next time.